This is learning from data. We'll be looking at, given financial information about a company, can we predict its bankruptcy? This is the main research question we'll be attempting to answer this coursework. It'd be useful to know if a company will go bankrupt. For example, if you're a shareholder or investor, you may have financial incentive to know. Our dataset comes from the Taiwan Economic Journal between 1999 and 2009. The data contains 95 attributes and a truth value, which says if the company actually did go bankrupt or not. Some of the attributes are tax rate, cash flow per share, and working capital to turnover rate. The dataset was found on Kaggle. Some of the reasons this data is chosen is due to its high usability score and clear documentation. To try and solve this problem, multiple different machine learning techniques were employed, such as linear regression, decision tree, random forest, and multi-layer perceptron. We'll look at them now. Linear regression is a machine learning method which attempts to fit a line of best fit and then predict a value based on the correlation from the data. While it's usually used for regression problems, it can also be applied on classification problems. However, doesn't always perform as efficiently due to the assumption that all data has linear relationship. That being said, we'll now look at decision tree, which is a tree-like structure where each of the nodes of the tree is a decision to be made. The leaf nodes are then the class label after all decisions have been made. Decision trees are a popular machine learning algorithm because they're simple and easy to understand. Random forests are a collection of decision trees which work together to choose a class. The most chosen class by each of the individual trees is the output class. Unlike decision trees, however, they're not as prone to bias or overfitting because there are multiple trees in the forest and they can overcome bias. The trees are often better if uncorrelated with each other to cover the data better. Multi-layer perceptron, or feed-forward neural network, is a method where data is fed through a network of fully connected neurons. The input layer for us will be 95 neurons, as that is the number of attributes we have, and the output layer is 2 for a binary classification problem like ours. Nonlinear activation functions are used between layers, such as ReLU or sigmoid. We'll also be using ADAM, which is an optimization to gradient descent, which combines AdaGrad and RMS prop to efficiently converge on a local minima. Our dataset is extremely unbalanced. From the figure you can see only 3.2% of the companies went bankrupt, which is how real world data would work, because not every company will go bankrupt. This provided us with some issues in training, because if the model predicts no bankruptcies whatsoever, it would be correct 96.8% of the time. This means we need to find a way to make the dataset more balanced for training purposes. We can fix the unbalanced data problem with SMOTE, which is synthetic minority oversampling technique. SMOTE works by creating synthetic data for the minority class, which in our case is a bankruptcy value of 1. New data is created by taking a point from the dataset and finding its k nearest neighbours, then take a vector between one of those neighbours and multiply the vector by a random value between 0 and 1. This then points to one of the new synthetic data points. As you can see, we now have a balanced dataset with 50% of each class represented. This should help us train more efficiently. Linear regression performed worst, as we'd expect, since it's the simplest approach. It correctly identified 1,028 and misidentified 336. Decision tree performed slightly better with fewer false positives, but still not great. Random forest was better again and detected almost twice as many true positives with a total of 28. And then the best model was multi-layer perceptron, which, while not detecting as many true positives as random forest, it didn't misidentify as many either. Here we can see receiver operating characteristic of each method. We can look at the area under the curve as a metric to indicate success. As you can see, the multi-layer perceptron has the highest area under curve with a value of 0.7. This shows again it was the most successful model. A value of 0.5 would indicate random results, and so we achieved slightly above that. Now we will look at the limitations of our data and methods. Since our data has 95 different attributes with varying relevancy and size, it can be tricky to find which ones are necessary to use and which will just hinder us. Linear regression is primarily used on data with linear relationships, which ours is not, and so might not have been as effective. Decision trees can be easily overfit, which means they won't be as effective against new data, and random forest may be more effective when data trends in an easier way for it to understand. To conclude, we have found difficulties on training a model to predict bankruptcy. However, to an extent, the multi-layer perceptron will work. We compared many different methods and seen how they compare against each other, with linear regression performing worse than any of the other methods, and multi-layer perceptron performing best. Thank you.